Okay, welcome back everyone. So in this video we're going to be talking about some important vocab terms regarding motion. We're going to talk about distance, displacement, speed, and velocity. And depending on what your book says, you might have slightly different variables that are used. It's important to take a look and just see what the book says. So we'll start with distance. One way to think about distance is it's simply the total path length. It's the total path length traveled. So if I get up in the morning and drive my car and I look at my odometer as I get into my car and it says something like 62.0 miles, and then after all the twists and turns I take on the way to school it says 68.3 miles, I would just say that the distance that I've traveled is 6.3 miles. Now, something important about distance is it's a type of variable which we call a scalar. So a scalar is something which just has a how much. Technical term for that would be magnitude. So it's just how much. How far did I travel? 6.3 miles. Other examples of a scalar could be mass. Okay, I have a mass of 70 kilograms. Maybe time is another example of a scalar. So maybe 15 seconds. Okay, so these are quantities that just have magnitude. Alright, so distance is usually written with a d. Okay, and usually we're talking about distance as from one place to another, the total amount of path we've traveled. Alright, now we're going to contrast that with displacement in a moment, but before we get to that, let's quickly talk about speed. Alright, so speed is just the rate at which distance is traveled. So it's how fast, okay? Because of this, speed is also a scalar. We could think of it as just simply how fast. So there's different types of speed. You could talk about the speed for an entire trip. So v, that's speed, average. Okay? Another way this is sometimes written is v with a bar over it. So this is average speed. And that's just simply the distance that we've traveled divided by the time interval. Okay? So this time interval, delta t, remember the delta means change in, so it's change in time, and that's really equal to some final time minus some initial time. Now most of the time we say that this initial is 0, so delta t is just equal to t, the amount of time it took us. And that's kind of a fine point. Okay, so like in problem 111, this is from the Chem-Phys book, if we went a distance of 10 miles and divided by 0.05337 hours, we would have an average speed of 187 miles per hour. Okay, so that's v average is a total distance over a total time. Okay, or for any interval of time. Now, you can also have instantaneous speed. Okay, so instantaneous, I can't spell it ever. Instantaneous speed is the exact speed at one moment in time. Okay, for you math people out there, it's the limit as delta t goes to 0 of a change in distance over a change in time. That's v instantaneous. And we're not going to worry too much about that limit. If that's something new, don't worry about it. A way to think about it is if I look at the speedometer in my car, what is it saying right now? That's the instantaneous speed. Okay, so if I just take a picture of one moment in time, how fast am I traveling? That's instantaneous. Okay, now that's also a scalar. It's just a number. How fast are we going? We're going to contrast this now with displacement. We're going to go to displacement. So displacement is the straight line distance between 2 points. And we also have to talk about the direction from the starting point to the finish. And I'm going to pause here for a second because Dr. Weiner's here to say hi. Okay, and we're back. Dr. Weiner says hi, by the way. So, displacement is the straight line distance between 2 points along the direction from the start to finish. What do we mean by this? Let's say that this is my house, point A, and this is ETHS, point B. Okay? Now, in order to get from my house to ETHS, I can't fly there. I have to drive, something like 6 miles this way, and it's not 4 miles east, but I'm just using this scale. Okay? So the distance that I would travel would be 10 miles, 6 plus 4. But the displacement would go from the start to the finish, and that's not 10 miles. As a matter of fact, I have a right triangle, Pythagorean theorem, 36 plus 16, I would have something like the square root of 52 miles. And we don't care about the square root for right now. Okay, but this is the displacement. And not only would I talk about the square root of 52, but I would also give some sort of an angle. And we'll talk more about how to do that a bit later on. So now we're getting into a different type of quantity. We're talking about a vector. And displacement is the first example that we will see of a vector, which is a quantity that has both magnitude and direction. So in other words, it has a how much and it has a which way. Now, in order to show that something is a vector, your book makes it a bold symbol. So they go D. Well, we can't really do that, okay? So we write an arrow to show that it's a vector. So it's got direction as well, okay? And displacement is actually defined as a vector which relates our starting and final positions. And we'll say a little bit more about position a bit later on. Now, to continue this thought, instead of speed, which is just how fast we're going, we can talk about velocity. And velocity is how fast and which way. So there's the vector part of it. And instead of writing a V, we put a V with an arrow above it. And just like you guessed, velocity is going to be displacement over elapsed time. Notice that time is not a vector, but displacement is, and so is velocity. We can also have average versus instantaneous velocity. It means the same thing as speed. And then finally, we can have other vectors such as momentum and force. Field is a vector, but we'll talk about all of these a bit later on.